Hello and welcome to this class. In this class, we are looking at the topic numerical processes, indices and logarithm, and we are looking at the subtopic laws of indices. By way of definition, we can say that indices, which is the plural form of index, simply means numbers that are raised to a power. For example, if you have a number such as 4 and we raise it to the power of 2, so we can say this means 4 in two places, which is 4 multiplied by 4, which gives us 16. So it refers to numbers that are structured in this manner, meaning a number that is raised to the power of another number to be called an index. The laws that guide all the numbers that look like this are called the laws of indices, and this is what we are going to be looking at under this subtopic, laws of indices. What I will do now is that I'm going to be writing out each of those laws. We are going to look at the first 4 laws. We are going to look at examples under them. After that, we are going to be looking at some extensions of these 4 laws of indices, and we also look at examples under them. Let me write out the laws guiding indices. So the first law we are going to be looking at is the multiplication law. It's generally known as the multiplication law. And the way this law is structured, let's say we have a number, it can be any number, x, and this is raised to the power of a, and this is multiplied by another same number, which is x again, raised to the power of b. To simplify this, using the law of indices, we are going to have x and then the first power, which is a, plus the second power, which is b. One thing I want you to note here is that the first number that we have is x and the second one also is x. If you have x and y, this is not going to be feasible. So if you have two different numbers raised to two different powers, we can't just apply this law on them. It has to be the same number raised to the power, or it can be different power or the same power. We're going to be looking at some examples under this. Let me just write out the 4 laws first. So the second law of indices talks about division. If you have a number, let's say x again, raised to the power of a, and this is being divided by that same number, but in this case raised to the power of b, how we treat it is going to be x, which is the number that we are considering, and then we pick the power of the first number, which is a, then we subtract the power of the second number from it, b. So take note, for the first part, when we have the multiplication, we add the powers, and when we have division, we subtract the powers. The law is very simple. And going quickly to the third law, if you have, probably you have been hearing this all around, that any number raised to the power of 0 equal to 1. So if you have a number given x, which is raised to the power of 0, so this equal to 1. In as much as x, take note that in this case, x must not be equal to 0. So if x equals to 0, this violates the law. So just take note that whenever we have a number that is raised to the power of 0, the answer is going to be equal to 1. Just know, any number raised to the power of 0 equal to 1. The law is very simple. Now, to the fourth law, before we look at examples, if you have a number, x raised to the power of a negative number, let's say raised to the power of minus a, how we treat this is going to be 1 all over x raised to the power of that number, which is a. So we have x raised to the power of minus a, and this is being simplified into 1 over x to the power of a. So these are the common 4 laws of indices, though we are still going to be looking at some extensions of this law, but these are the first 4 that we are going to be looking at first. So let me look at some examples so that we further understand this better. Examples. Number 1. If you are to simplify the expression 10 raised to the power of 2 multiplied by 10 raised to the power of 3. If you look critically here, you see that this fulfills the first law, which is a number raised to the power of x multiplied by that same number raised to the power of b. So we have the number that we're looking at. Our x in this case is 10 and 10. So going by this law, we see that we are going to take x, which is in this case 10, and then we raise to the power of a plus b. So our a equal to 2 and our b equal to 3. So this is going to be raised to the power of 2 plus 3. So this gives us 10 raised to the power of 5. So we can further simplify this more. But for now, since we are looking at indices, I will just leave the answer as 10 to the power of 5. But you can also write the answer to 10 raised to the power of 5. It's very simple. Also, let's look at another example. If you have another example from the second law that says, let's say we have 22, and this is just a letter, and this is raised to the power of 7 divided by 2 and raised to the power of 3. Now, I want you to critically look at this particular example. You have 22n raised to the power of 7 divided by 2n raised to the power of 3. If I'm to ask you that what is actually raised to the power of 7, it is not 22n. What is raised to the power of 7 is n. 22 is on its own, n is on its own, raised to the power of 7 is being divided by 2, n to the power of 3. So 7 doesn't cover 22 and n, it covers only 7. You should have to take note of this. And 3 here also doesn't cover 2, it only covers n. So what we have is just n raised to the power of 3 and 22 and n raised to the power of 7. So we are going to treat 22 and 2 as an individual numbers. How we are going to solve this is you can simply take 22 divided by 2, and then if you look at it critically, we can simply, let me go in another way so that we can further understand this. Let's say we want to write this using the long division. You can say 22 n to the power of 7 divided by 2 n to the power of 3. So this is also the same as saying 22 times n to the power of 7 over 2 times n to the power of 3. And this is also the same as saying 22 over 2 multiplied by n to the power of 7 divided by n to the power of 2. So we now have 22 and 2 standing alone and n standing alone also. So we can simplify this further. We know that 22 over 2 equal to 11. And then we now have multiplied by n to the power of 7 divided by n to the power of 2. If you look critically here, you see that this expression has satisfied our second law. We are able to reduce it to our second law. So we can apply the second law on it. And then we have 11 multiplied by n. So you have 7. And second law says we have to subtract the second index from the first one. So we have 7 minus 2. Oh, this 3. I've been using 2. N to the power of 3. N to the power of 3. N to the power, I'm sorry for that. N to the power of 3. So we have 11 multiplied by n. 7 minus 3 is 4. So we have 11 n raised to the power of 4. 11 n raised to the power of 4. So let's look at a third example. This is not like an example. It's very simple. If you have, let's say you have 100 raised to the power of 0, this is surely going to be 1. Any number at all that we have raised to the power of 0 is going to be 1. And if you have a third example, a fourth example that says r multiplied by r raised to the power of 0 multiplied by r raised to the power of minus 5. Now this is a combination of some of the laws. We have r multiplied by r raised to the power of 0 multiplied by r raised to the power of minus 5. We see here that the third expression here fulfills the fourth law, which is the law that we have here. And we can also say that r standing alone is equal to r raised to the power of 1. So, and we know that r raised to the power of 0 equal to 1. So, to simplify this, we can say r raised to the power of 1 multiplied by n raised to the power of 0 equal to 1 multiplied by, how are we going to simplify this? This is going to be 1 over r to the power of 5. Now, if you multiply 1 by r, we are going to have r. So, this is basically r raised to the power of 1 multiplied by 1 over r to the power of 5. So what we have is this case when we have r raised to the power of 1 over r raised to the power of 5. So this is also the same as the second law. We can simply write this down as r to the power of 1 divided by r to the power of 5, which is basically as we see from the second law that r equal to 1 minus 5, which is equal to r raised to the power of minus 4. We know that 1 minus 5 equal to minus 4. So to simplify this further, we can simply write that r, we can have, using the fifth law again, the fourth law, we can say this is equal to 1 over r raised to the power of 4. And there we have our answer, which is 1 over r raised to the power of 4. So these are the first 4 fundamental laws of indices. Check very well. Check if there's any question. You can feel free to drop the question in the comment section. So these are the first 4 laws of indices. Now we are going to be looking at some extensions of this law. So here we have the product law and also the fractional indices. Before we look at the extension of the laws of indices, I want you to try the following exercises to test what we've learned thus far. So try to solve this. Number 1 is if you have 10 to the power of 5 multiplied by 10 to the power of 4. Number 2, we are just going to look at just 4. If you have 9 multiplied by 10 to the power of 9, and then you have everything divided by 3 multiplied by 10 to the power of 3. So the third one, if you have something of this nature, 3x, note here that 3 and x are together inside the brackets and everything is raised to the power of negative 3. And lastly, number 4, I want you to try this. If you have a raised to the power of 9, a raised to the power of negative 9 divided by b raised to the power of 0. So I want you to try this, and if you have any problem while trying to solve this, you can comment in the comment section below. And if you're able to solve this successfully, feel free to drop the answers in the comment section and I'll get back to you as early as possible. So let's, in the next class, look at the extension of the 4 laws of indices.